Hello and welcome to my short presentation demonstration of the TMP006 temperature sensor. So what I have here is the Tiva C 123. I have the Educational BoosterPack slapped on top. The TMP006 is located here, and it's connected using I2C. Let's take a look at the code. I attempted to use IQ Math to optimize the power consumption and performance of the TMP006 temperature calculations. Was not able to get it to work though. For some reason, after I put a bunch of function calls in using this library, it would just print 0. Was not able to determine why that was happening. So I just switched back to using the CPU intensive standard library, math library. Okay, so here are my prototypes. I have a configure UART, initiate I2C, write 16 bits, read 16 bits, initiate TMP006, and the get temp function. I also have a global for T object. I don't need this anymore. I can remove it as a global. I had this for debugging purposes, but I just decided to leave it in. Here is my main. We're initializing the clock and the output. We have some local variables here, and initialize UART I2C. Print to the UART, make sure it's working. Initialize TMP006. And then here is a forever loop where we are averaging the temperature. And then here is a small conversion so that I can print out a double to the UART. Do this by taking the whole number integer values of the floating point number, and then I multiply the floating point, well, it's actually a double, but I multiply the double by 1,000, and then I take the double that's multiplied and I subtract out those most significant digits that are the whole number. The result is, like, let's say this is 22, or whatever it is, then this will be 22,000 and some change, and we just want the change. So we're taking the whole thing and we're subtracting out the 22,000, so we're only left the change. And then that change is going to be the decimal point, everything after the decimal point, so the fractional portion of the number. So we're simply saying temperature value, printing out that whole number, and then we're doing a decimal point, printing out that decimal, and then going to a new line. And then we're doing a delay and resetting. Here's my initiate I2C, write I2C, read I2C, initiate TMP006, and here's my get temperature function. Again, we're not using the QMath library. Figure UART. Let's go ahead and build. You can see it compiles. We are now going to debug. My program was running last time. Hear that UART terminal, and we are ready. So play. Prints out the device ID in decimal, and then you can see we are having some values printed out to the terminal. It is kind of cold in my room right now, so yeah, I think 72 is about right. If I move my hand in front of the sensor, you can see it heats up quite a bit to my body temperature, more or less. Now, there is optimization to be done. This has to be calibrated to the material that it's reading temperatures from. Some calibration will give more accurate results, but you can see that working. We're getting those values off of the sensor. Thank you for watching.